In the previous exercise, we learned how to take logarithms of numbers that were powers of 10. But we should be able to look at numbers that are in between powers of 10. So let's consider, first of all, a couple of examples for large numbers. Let's consider the number 10,000. In chemistry terms, these are relatively small numbers, but when compared to something like a mole. But let's compare 10,000 and 100,000 and review by looking at the scientific notation and the logarithm of the number. In scientific notation, 10,000 is simply 10 to the 4th, 100,000 is 10 to the 5th. And since the logarithm gives us the exponent of 10, the logarithm of 10,000 is 4, and the logarithm of 100,000 is 5. Now there are plenty of values in between these numbers. So for instance, let's consider the number 50,000. In scientific notation, this would be 5 times 10 to the 4th. Clearly, as we look at the trend in logarithms, as the number gets bigger, the log gets bigger. But 50,000 is bigger than 10,000 and less than 100,000, so the log has to be somewhere between the 4 that we got for 10,000 and the 5 that we got for 100,000. So go ahead and enter it into your calculator. Pause the video if you need to. And you should find that the logarithmic value comes out to be 4.7, okay, which is nicely situated between the 4 and the 5. Now you'll notice it's not halfway between as you might expect. It's at 4.7. A logarithmic scale is not linear, so it won't come out at the halfway point. We could consider another value, 72,000. Okay, so which is between the 50,000 and the 100,000. So we'd expect a log value that's between 4.7 and 5. In scientific notation, you could write that as 7.2 times 10 to the 4th. And when you put that into your calculator, you should get 4.9. Feel free to pause the video and take the log of 72,000 and see what happens. The general trend is as the numbers get bigger, the values of the logarithms get bigger. But once again, as the numbers get 10 times bigger, the logarithm only goes up by +1. Now that's looking at large numbers. What's a little more confusing is to look at small values, but the concentration values that we're going to look at are very small. So let's keep this exercise going by considering 0.001, which is small, but not as small as the concentration values that we'll be looking at, and 0.001. So we have 1,000th and a 10,000th here. In scientific notation, the first would be 10 to the -3, the second would be 10 to the -4. When we look at the logarithms, since it's simply the exponent of 10, you can try it in your calculator, but you should be able to recognize that that should be -3 and -4 respectively. But what happens if we have a number in between, like 0.0005? Notice 0.005 is not in between. If I put 0.005, it would have to be up here. It's not in between because it's 5 times larger than 0.001. So in fact, this time we are getting bigger as we go towards the top. As we go to more decimal places, the numbers are getting smaller, not larger. So 0.0005 is halfway, well, not quite halfway, but it's in between the two values that are in black. So let's write that in scientific notation. That would be 5 times 10 to the -4. So notice it looks a little more like 0.001 than it does 10 to the -3. But since it's 5 times as large as that, it's bigger. When you go ahead and take the logarithm, feel free to pause and do that, you end up getting a value of -3.3. So notice bigger is in this direction, negative 3 is bigger than negative 4, even though the absolute values reverse that. The size of negative 4 is bigger than the size of negative 3. The value is going up as we go from negative 4 to negative 3. But once again, the values are going up in this direction by plus 1 every time that in this direction we go times the number grows by a factor of 10. So we add 1 to the logarithm every time the number grows. But we can have logarithms that are in between integer values, whether they be for large numbers or small numbers. The logarithms work out very nicely for powers of 10 when we're working with a base 10 logarithm, as we are. But you can get the values in between. It's very hard to compute, but your calculator will do it nicely for you when the power, when the number isn't just an easy number of factors of 10.